Hello everyone and welcome back to doing videos. We're on to Unit 3, Radicals and Rational Expressions. So we're going to get right into it. So consider that the product of 3x plus 2 and 2x plus 5. So we can use the area model. There's really addition signs in here. When you use the area model, you're going to do 3x times 2x gives us 6x squared. 3x times 5 gives us 15x. 2 times 2x gives us 4x, and then 2 times 5 gives us 10. And when we add them, remember that we can add like exponents, or like terms, excuse me. And so we're going to get 6x squared plus 19x plus 10. So we can see that if you were not to do it that way, and we were doing it to do the double distributive, double distributing, which is what we call it, where we take 3x plus 2 and 2x plus 5, and we take it and we double distribute. 3x goes to 2x, 3x goes to 5, 2 goes to 2x, and 2 goes to 5. You'll notice that you get the same thing that we did right here. You would get 6x squared, 3x to the 5 plus 15x plus 4x and plus 10, and you'll notice that we go right down there. We do not use the area model. I wanted to demonstrate it, but we do not use the area model. We use double distributing. So what I would like you guys to do right now, I'll do one more. Why don't I do D? What I would like you to do is A, B, and C. So I'll do D right now though. X to x squared to 10, negative 4 to x squared, negative 4 to 10. So we're going to get x to the fourth. You add exponents when you multiply. X squared and x squared gives you x to the fourth. X squared to 10 plus 10x squared minus 4x squared and minus 40. And so that equals x to the fourth. 10 minus 4. Should be a squared there. Sorry about that. 10 minus 4 gives us positive 6x squared and minus 40. Let me just show you with F. F says double distribute the 2 as the last step. You cannot do it first. We need to write it out as x minus 4 times x minus 4. And then you will still write it after you double distribute. So right now, pause the video, please, and write and do A, B, C, E, and F. And so hopefully these are the answers you got. This is also the answer, so please, you can pause, check your answers, make sure they are correct, and then we'll move on. So we're on to GCF factoring now. GCF factoring is the same idea as factoring anything. You have to find the common factor. Sometimes, or usually, we call it the greatest common factor. So what is that? Well, we need to look to see what's in common between a 2 and a 6. Now, we can factor 2 into 2 times 1, we can factor 6 into 6 times 1, and 2 times 3. Notice that 2 is the greatest common factor. And so we're going to pull a 2 out, which means that we're really dividing by 2. So when I take a 2 out, I'm saying I'm going to take it out and then I'm going to get x minus 3. If I was to redistribute that back in, I would get the same binomial here. This is what it looks like factored by taking the greatest common factor out. Let's go look at 15. We're going to get factors of 6 and 15. 1 and 6, 2 and 3. 15 goes 1 and 15, and then 3 and 5. 3 and 3 are the greatest ones. So I'm going to divide each of them by 3. Put the 3, the greatest common factor, out in front. 2x plus 5. We like the number 6. 6, 1 and 6, 2 and 3. And 14, 1 and 14, 2 and 7. Notice that 2 is the greatest common factor there. So again, 2. Divide by 2, divide by 2, we're going to get 3 minus 7x. But what can happen when we have a variable involved? Well, the same idea, we're still going to find the greatest common factor, but now the variable, there's two x's here. There's x times x, and this one there's only one x, so I can only circle one that is in common. And I can still take a 3 out, so I divided by 3x and divided by 3x. Notice that when I have two x's and I take one out, I have one left over here. So let's look here. I have 20 and 5. The greatest common factor here is going to be 5. I can take a 5 and 20 is divisible by 5. And I have an x and an x squared. And I can circle one each. So I'm going to divide by 5x. 20 divided by 5 is 4. X divided by x is 1. So I'm left with just 4 minus 5 divided by 5 is 1. And I have an x left over. And so there we go. Notice that in D, we have 30 and 20. Notice that they're each divisible by 10, so my greatest common factor will be 10. And notice I have x squared here, but no x's here. Can't take any x's out, so I'm just going to divide by 10. Put the 10 out in front. You got to always remember to put the 10, the greatest common factor, out. 3x squared minus 2. Now, we can also factor trinomials. Nothing different here. We just have to find the greatest common factor. Notice 10, 20, and 5. 10, 20, and 5. 1 and 5. This is going to give us 1 and 20, 2 and 10, 4 and 5, and 1 and 10, 2 and 5. Notice that each of them have a 5 in it, so we're going to take a 5 out. Notice that the 5 doesn't have an x, but the x squared does, so there's no x that we can take out. Okay, and then let's try D. Going to D, we have 3 x's here, so this would be x times x times x, just x, and x here, so my GCF is going to have an x with it. And now let's figure out 6, 15, and 21. They're all divisible by 3. So my GCF is going to be 3x. So I'm going to take a 3x, 3x, and 3x. Keep my 3x out in front and get 2x squared because I had 3 x's and I took 1 away. I'm left with 2. Here I have 2 x's. I factored 1 out. I'm left with 5x. In this one I have 1x and I took it out to factor it, so I'm left with no x's. That should be a minus though. So minus 7. Moving on. How to factor trinomials. When we look at trinomials, we need to figure out the factors of C that add or subtract to B. So this is how I want you to think of it. Factors of 16 that subtract. Why am I saying subtract? Because it's a minus sign. To 6. So I'm going to write my factors of 16 down. One and 6, 2 and 8. That's it. Which one of the 1 and 16, excuse me. Which one of these subtract to 6? Bingo, 2 and 8. So I'm going to be left with, when I factor a trinomial, be left with x and x. Factors of 16 that subtract to give me 6 are 2 and 8. I need a negative 6. So I need my 8 to be negative and my 2 to be positive. Why? Negative 8 plus 2 gives me negative 6. Negative 8 times 2 gives me negative 16. So same idea here. Factors of 8 that add, notice how I'm doing this, to 6. 1, 8, 2, 4. Which one of those add to 6? 2 and 4. X plus 2, x plus 4. Why do I know they're both positive? Because I need to add to 6. Let's look at 3. Factors of 15. 1 and 15, 3 and 5. Excuse me there. Which ones add to 8? Well, 3 and 5 add to 8. But I need to add to negative 8. The only way to get two numbers to be a negative when adding are to make them both negative. Notice that it does not matter which order they go in. I could have written x minus 5 and x minus 3. There is no order. We're going to look at number 5 here. Notice that there is nothing inside in the b value. So it's x squared plus 0x minus 36. Factors, again, factors of 36 that subtract to 0. Well, factors of 36, 1 and 36, 4 and 9, 6 and 6. Which one of these subtract to 0? The 6 and 6. So I'm going to rewrite it as 6 and 6 subtract to 0, so positive 6 minus 6. So I know I went through that fairly fast. Please complete number 6 on your own. And with that, we'll end the video for today. Please finish number 6, and I will see you in class. Have a good one.